for these notes we're going to look at how adding or multiplying different parameters to our functions transforms the way our functions look like on a graph. And it's important to remember that we've learned about this before, and these parameters work for any type of function. So if you learned transformations well before, you should be able to predict these before I even go through the notes. Let's start with our parent function. That's something that we've already talked about, so I expect you to be able to figure out what it is. So take a minute and see if you can find out what the parent function for the quadratic function is. And it is f of x equal to x squared. Okay, so now I'm going to test out different parameters, so adding 4 to our function. So our function is already x squared. F of x is just x squared, and then I'm just going to do plus 4. Okay, and then I'll do the same thing, but this time I'll subtract 3. So x squared minus 3. Okay, so let's start by filling in a table, and then we'll graph our coordinates from a table and see what the transformations actually look like. So starting with x squared, negative 2, and I'll do a calculation over here just to show you what I'm doing. Negative 2 squared means negative 2 times a negative 2. Well, a negative times a negative is a positive, so 2 times 2 is 4. Okay, I'll do the same thing. A negative 1 squared would be 1. 0 squared would be 0. 1 squared is 1 times 1 is 1. And 2 times 2 is 4. Okay, so I got my parent function graphed. Let's look at the table for adding 4. Well, I can just simply take f of x is already x squared. So when I substitute negative 2 into x squared, I got 4 out. And now I just want to add 4 to that. So it's just 4 plus 4 is 8. 1 plus 4 is 5. 0 plus 4 is 4. 1 plus 4 is 5. And 4 plus 4 is 8. Okay, same thing with y3. I've already calculated what x squared equals for these different values of x. And now I can just simply subtract 3 from those values already calculated. So 4 minus 3 is 1. 1 minus 3 is a negative 2. 0 minus 3 is a negative 3. 1 minus 3 is a negative 2. And 4 minus 3 is 1. Okay, so I want to graph these different functions and see how they are transformed. So I'll start with my parent function. So I know I have a coordinate at 0, 0. I have a coordinate at negative 1, 1. And 1, 1. And I can already see that it's changed directions, and those are symmetrical, so I could also tell that my vertex is going to be at 0, 0. I also have a point at negative 2, 4, and 2, 4. And I could keep going, and I know it's going to go to 3, 9, so it's going to be out that way. So the parent function for our quadratic function looks like that. Now let's look at what happened when I added 4 to the function, when I add 4 to f of x. So I have a point at 0, 4. I have a point at negative 1, 5 and 1, 5. I have a point at 2, 8. And I have a point at negative 2, 8. Now let's connect these points with a smooth curve, and it looks something like that. Okay, let's graph the y3, and then we'll talk about what happened to this transformation. So we have negative 2, 1, 2, 1, negative 1, negative 2. 1, negative 2, and 0, negative 3. Well, notice that the shape of the functions are all basically the same. We haven't changed the shape, but the shapes have moved. For the purple one, our vertex moved up 4 spaces, and you could actually take every point on the parent function and notice that each point moved up 4 spaces. So if you're adding 4 to f of x, our function will be moved up 4 spaces. If you subtract 3 from f of x, our function will be shift down 3 spaces. So adding a positive value will move up, subtracting a value will make it move down.